Hello and welcome to the Logarithm Solving Part 2 video. In this video, we're just going to continue solving with logs using more of the rules than we did in our last video. If you take a look at the blank notes, you'll notice that there are 33 questions, so many questions for you to practice with. I'm just going to be going over 7 problems in this video. So let's get started. Problem number 1, we're just going to look at problem number 1, that is log base 2 of x plus 2 plus log base 2 of 5 is equal to 4. So for this problem, we have two logs of the same base being added together. So we're going to multiply their arguments and get log base 2 of 5x plus 10 is equal to 4. And now this kind of looks like the problems from our last video that we did. We have one logarithms that equal to a number, so we can use our rearrangement of base, answer, and exponent, or log bay, to become 2 to the 4th is equal to 5x plus 10, or with our base, exponent, and answer. So we continue simplifying. 2 to the 4th is 16, which is equal to 5x plus 10. I'm going to subtract 10 on both sides and get 6 is equal to 5x, and then divide both sides by 5 and get x is equal to 6/5, or 1.2. That is acceptable as well. So as you can see, we're just using our log rules as we would, but in this next problem, we're going to come across extraneous solutions. So as we're working through, think if you can remember, what is an extraneous solution? So the next problem we're going to look at is problem number 4. That's going to be log base 3 of x plus log base 3 of x minus 2 is equal to 1. Just like in the previous problem, we have two logs of the same base being added together, so we're going to multiply their insides. And get log base 3 of x squared minus 2x is equal to 1. Now we have one log set equal to a number, so we can use our rearrangement of log bay and set this up as 3 to the power of 1 is equal to x squared minus 2x, or base, exponent, and answer. Now 3 to the power of 1, that's just 3. So 3 is equal to x squared minus 2x. Now I notice something squared, something with a variable, and something with a constant. So I'm probably going to have to factor or use my quadratic formula. But in order to do either of those, I need to set the equation equal to 0. Now you can move the x squared over here, but that's going to give you a negative x squared and make things very much inconvenient. So we're going to move the 3 over to this side of the equal sign instead, and get 0 is equal to x squared minus 2x minus 3. So you can use the quadratic formula, but factoring will be faster. We're looking for two numbers that multiply to negative 3 and add to negative 2. So those numbers are going to be x will have a negative 3 for x minus 3 and a positive 1 for x plus 1. So now that we have two factors, we're going to set them both equal to 0 and solve. So we get x is equal to 3 and x, is this still recording? Sorry, something weird happened. And x is equal to negative 1. But wait. These are not both correct answers, because we know if we have a negative number inside the argument, that's not going to work. That's going to be a domain error, non-real answer. It's just not going to work for us. So if I take a 3 and I plug it in here, log base 3 of 3, that works. If I plug it in here, log base 3 of 3 minus 2, or 1, that works. But if I plug in negative 1 in either of these logs, it's going to result in a negative number in the argument. So this is an example of an answer we can solve for, but doesn't actually work. So if you remember what that is an extraneous solution, because a logarithm's argument, or that thing inside the parentheses, cannot be negative. So make sure that as you're going through and you're solving, you're always just kind of taking a notice of, hey, if I was to take this number and plug it in here, would that work? So you can do that in double checking your work or just kind of saying, hey, will this work for the problem? So our only answer for this problem is going to be 3. So sometimes we'll come across extraneous solutions. Just make sure to always look back at that. So let's take a look at a few other problems. Some of them involving exponent rules. So just because we're continuing with a new unit, I'm using air quotes, doesn't mean we can forget the old units. So let's take a look at problem number 9. Problem number 9 is log base 10 of x squared is equal to 6. So we got a log set equal to a number. Let's use our rearrangement so that we end up with 10 to the power of 6 is equal to x squared, or base, exponent, and answer. Now you can go through, find 10 to the 6, and then take the square root of that. However, what might be faster is if I put both sides to the power of 1/2, since putting something to the power of 1/2 is the same as square rooting. Now if I was to multiply this 2 and this 1/2 together, I just end up with x, or an x to the power of 1. So those things will cancel out. But if I do this on my left side, 6 times 1/2, or the square root, that's going to give us 10 to the power of 3. So that's going to make our lives a little bit easier because this will go a little bit faster. Now you can find 10 to the power of 3 and say that 1,000 is equal to x. So don't forget, exponent rules are still important. Now for our next problem, I've had a lot of people ask me about natural logs. Natural logs are exactly the same as logs, except they have a different base. It's a base of e instead of 10. So if we were to just try something here, let's see, 12, but natural log of x is equal to 2. Remember, the base here is e, not 10. So if we were to rearrange this as our base, answer, and exponent, this becomes e to the power of 2 is equal to x, or base, exponent, and answer. The cool thing is, if we're going to leave things exact, e in itself is a number. So I can just leave my problem here and be done with it. So if you get an answer with e as part of your answer, that's okay. E is still just a number. So that works. Now, one of the new things we learned today in class was about our change in base rules. So I want to practice that a little bit, especially when maybe you might need to use some other algebra skills along the way. So if we take a look at problem number 19, we only have 3 more problems left. Problem number 19 is 2 to the x is equal to 46. So in this case, I don't have any logs, only exponents. Well, I can use my rearrangement here. If I have my base, exponent, and answer, I can rewrite this as log base 2 of 46 is equal to x, or base, answer, exponent, or log bay. Now, some calculators can deal with this base of 2, some can't, so I want everyone to be able to show me that they know their change in base rule. I can go log of 46 divided by log of 2, and plug that into their calculator to get x. Now, I'm going to have us round to the 3rd decimal place because this is going to get us something not a pretty number. But when we plug this in our calculator, we should get 5.524 as our answer. So let's try just 2 more. The next 2 problems we're going to do just have a couple extra steps to them, just 1 extra step to them each from what we just did. So the next one is problem 22. If we have 5 to the 3x is equal to 128, again, we're going to use our rearrangement. This is our base, exponent, and answers. And we want to rearrange this into log bay. So we'll have log base 5 of 128 is equal to 3x. Their base, answer, and exponent. So we'll use our change in base rule to have log of 128 over log of 5 is equal to 3x. Now the reason I wanted to go over this problem is because I know most people are just going to divide both sides by 3, but that's going to leave you with a triple fraction and make things super duper messy. So instead of dividing both sides by 3, I'm going to multiply both sides by 1/3, because this means the same thing. We're multiplying by 3, dividing by 3, those will cancel. But if we do that on our left side, it means we can multiply straight across and get log of 128 divided by 3 times log of 5 and get x by itself. So this is how it's going to look. Now when you plug this into your calculator, I want you to be very, very careful. The denominator needs to go in its own parentheses. So if you plug this into your calculator, you should have log of 128 divided by parenthesis 3 log of 5 double parenthesis. If you were to just do this without this second set of parentheses, you would take log of 128 divided by 3, and then you'd end up multiplying the whole thing by log of 5. So make sure that whole denominator is in parentheses. Anyway, when we plug this in our calculator and round to the third decimal place, we should get 1.005. Don't know what's happening. There we go. 1.005. So instead of multiplying to the x, what if we were adding to the x or subtract? So let's take a look at our last problem, problem number 29. All right, so let's see. Problem number 29 gives 2.2 to the power of x minus 5 is equal to 9.32. So this problem is really decimally, but that's okay. It's just a number that we're plugging into our calculator. And just like before, we are going to use our rearrangement of base, exponent, and answer to change it to log bay, or log base 2.2 of 9.32 is equal to x minus 5. From here, we will use our change in base rule. Oops, sorry, wrong color. There we go. And have log of 9.32 divided by log of 2.2 is equal to x minus 5. Now to get x by itself, I'm going to have to add 5 to both sides. And I'm okay if you just write this as log of 9.32 divided by log of 2.2 plus 5 is equal to x. I'm okay if you do that. You don't have to change the 5 into something with a log. But when you plug this into the calculator, I would find this fraction first. So I would find this first and then just add 5 to it, which is something you can completely do. It's not going to mess anything up if you do one part first and then the next. When we plug this into our calculator and round to the third decimal place, we should get x is about 7.831. And there you go. So this has been solving with a variety of different rules using logarithms. So if you can do this, I think you're going to be okay. Let me know if you have any questions, and I look forward to seeing you in class. Is equal